to lecture 61. So, we have been working with the reduction of the Lagrange planetary equation in terms of f r, f theta and f a. Now, we reduce this in terms of f t, f n and f a as it is written here. So, for this the model we are using see the in the earlier case our u r was in this direction and I will change the orbit little bit. And u theta was here in this place and then u a cap was like this. So, we have written here in this case what we are going to do, instead of u r, now we will be using u t cap, which is the tangent vector in the velocity vector direction. So, along this direction we have the velocity of the satellite. So, this is u t cap. And u a cap I will remove from this figure, because here in the it is appearing in the same direction as the vector I am going to show. So, this is u n cap. So, instead of u theta now we have u n cap and then perpendicular to this. So, u t cross u n cap, this we are going to write as u a cap. So, in both the cases, in the previous case also u a appeared and here also we are using this symbol u a. Okay. So, already we have discussed how this is u theta, because the angle theta is shown here. So, these things I am not going to discuss in this place. So, with the equation written for the f t equal to u t f n and in terms of f a. Now, in the previous lecture, if you see here we have got this equation in terms of f r. Okay. Perhaps we have done the mistake again here in this place e theta. So, this is 1 minus e square n a f r and then this part is f theta. So, this is the correction that we need to do, this is f theta. Okay. So, what we require that this quantity should be available. In all these places, if we replace in terms of f t, f n and f a. So, our the Lagrange planetary equation which reduced to the in terms of f theta, f r and f a. Now, this will get reduced in terms of f t, f n and f a, and this is pretty simple. Okay, not much work is required in this. So, f r we can write as f dot u r cap they are not perpendicular to each other, okay, but A and R, the f a u a cap dot u r cap, this quantity will be 0, because they are perpendicular to each other. A is a vector which is coming out of the paper okay, which I have not shown here. It is a coming out of the paper F A. Generally, it is shown by the head of the arrow. So, F A can be shown like this, or we will write as U A cap. This is U A cap, which is shown by this pink dot, which is coming out of the paper. And also the green one, the U A is in the same direction for U T, U N and U A set. So, we are left with estimating these two things, U T dot U R and U N dot U R. Now, here if we look in this place, so this vector is the tangent vector, and what this angle is, that we have to write here. Let us say this angle is alpha. Okay. Then we have U R cap dot U T cap, this will be equal to U R cap magnitude U T cap magnitude times cos alpha okay. And what this quantity will be? Now, going back and looking into our earlier lectures, if this is the r direction and this is the tangent direction U T cap here in along this direction, this is the theta direction, theta is like this. This angle we have written as alpha. Okay. So, V is along this direction, r is along this direction, and r times theta dot will be along this direction. So, what do we get from this place? Cos alpha equal to r dot will be here. So, r dot divided by V, r dot divided by V. So, therefore, this becomes equal to cos alpha, all these are unit vectors, and this quantity we are trying to evaluate here. Okay. So, we have U R cap dot U T cap equal to cos alpha equal to r dot divided by V. So, cos alpha becomes r dot by V. Similarly, the other things we can work out. Now, the next term is U n cap dot U R cap. The same way, this is the angle between the U n vector, this is theta, and r direction we have taken here U R cap, then V we have taken here in this direction, and then r times theta dot is along the U theta cap direction, r dot is along this direction. Okay. So, perpendicular to the U n vector, U n cap is this U t cap is along this direction. So, perpendicular to this will be I will use another color, this is U n cap. This angle we have written as alpha. So, if this rotates by alpha, this angle will also be equal to alpha. So, therefore, this quantity, then we are looking for the angle between U n vector and U r vector. So, how much this angle will be? This will be 90 plus alpha. So, the angle between them, this becomes cos, this quantity will be then equal to cos 90 plus alpha equal to minus sin alpha. And sin alpha is the quantity r times theta dot, the quantity which is here, this quantity is r times theta dot, and this quantity r dot is along this direction. So, sin theta then becomes sin alpha becomes r times theta dot divided by V. So, therefore, u n cap dot u r cap, this is minus r theta dot divided by V. Similarly, we have u theta cap dot u t cap u theta is this vector here and u t cap is this vector here. So, this angle is 90 minus alpha, okay. And therefore, this becomes cos 90 minus alpha equal to sin alpha, which we can simply write as r times theta dot divided by V. So, we have got all these terms here, and therefore, f r can be written as then f t u t cap dot u r cap plus f n from the our previous derivation. In this place we use it r dot divided by V, and then f n and u n dot u r is minus r theta minus f n times r theta dot divided by V. So, immediately we can see that our equation has got reduced into this format. So, just we need to replace in the equations we have derived here this f r, f theta. So, f r we have got here, and the same way we can get the other terms. F theta is the u t cap plus f n times u n cap, then f a times u a cap dot u theta cap. This is a vector, so it is a component along the u theta direction. And from this place then we have f t, all these are whichever the coplanar vectors and not perpendicular to each other, they will not be 0, rest others will be 0, and this term will be 0 because they are perpendicular to each other. U t dot u theta, this place r theta dot u n u theta u n u theta we have not worked out. So, we need to do that u n cap dot u theta cap. So, for this we can draw a figure here. This angle is here alpha, this angle is alpha. So, u n cap dot u theta cap, this will be cos alpha, and cos alpha is nothing but r dot divided by V. So, this is our f theta. Now, one more step is to be taken, that V needs to be replaced in terms of the common terms that we are using. So, here if we insert these values, okay, we will get the V, and similarly the R dot we have to write. And these things we have done in quite details while working with the two body problem and the central force motion. This is mu times L under root. Insert this R from this place. You can check it this part. Okay. So, for your ready reference, I am because we have done it quite in the early in the lecture. So, therefore, I am deriving it again here in this place. And this can be simplified to R dot equal to E sin theta. So, we need to replace L and R in this expression. R square theta dot this quantity is h. So, this is E sin theta h divided by L, okay. And h is mu times L under root. So, E sin theta so, finally, you can get to the format R dot equal to E sin theta times mu by A times 1 minus E square under root. As you can see from this, L equal to A times 1 minus E square. So, it is immediately visible. And therefore, V becomes R dot square plus R theta dot square R times theta dot whole square to the power 1 by 2 this. So, inserting these values, you can insert it and check it. This value will turn out to be mu times 1 plus 2 E cos theta plus E square A times 1 minus E square under root. And R dot already we have got here. So, we have R dot equal to E sin theta mu by A times 1 minus E square under root. So, we utilize these two expressions in the equation we have written here f theta and f r. And once we insert this, so this f r then gets reduced to E sin theta 1 plus E square plus 2 E cos theta under root times f n. We are replacing in terms of t and n. So, now this is f n as this part and this part. Similarly, the f theta gets reduced to 1 plus e cos theta So, this completes the derivation for this particular section. Okay. Now, what remains that if r is given, so this dou r by dou a, if it is not in the terms of force, then we have to estimate it. Say in the 3, we have one part main body here, and then the satellite is moving around this, and then it is perturbed by the third body. Okay. So, if it is perturbed by the third body, so for that the expression already we have written, like that expression we have written as r equal to minus summation of j equal to 2 to n j not equal to I 1 by r I j r I dot r j divided by r j whole cube. So, this expression we have written. Now, we need to express it in a particular way to formulate our problem, but that is going to take much longer time. So, therefore, I am not going to cover this part in the class. I will provide supplementary material for this. So, we will close this chapter here, and then we start with a new topic in the next class. So, we will close this here itself.